Hello and welcome once again to Civil Engineering Today, brought to you by the Boston Society of Civil Engineers. I'm Cristina Fragoso.
And I'm Brockman. And today we have Dennis Doherty with us. Dennis is someone I've known for a long time, and he is a trenchless technology guru. He works for Haley Aldrich, and he's the national practice leader for Haley Aldrich.
Welcome,
Dennis. Welcome.
Thank you. Thank you. Glad to be here.
And we haven't even defined what, of course, trenchless technology is. So before we go anywhere, of course, this involves, without using trenches, getting... You can explain it better than we can. I shouldn't say it. This is your world.
Well, another term for it's called no-dig. And really what it is you try to limit the amount of digging you're doing in the street, especially in an urban area. We have lots of utilities under the ground, and you get very busy streets. There's a lot going on, so for me to dig a long trench to put a big pipe in the ground, there's a lot of inconvenience to the public, and there's a lot more cost because you have to move other utilities around and repave the street, and so it gets very costly. So there's a method that's been around for maybe 20, 25 years in the United States, and it's called trenchless technology. Now, there's actually a whole family of methods. There's something called micro-tunneling.
Yep, what's that?
It's kind of like pipe jacking, where you're pushing a pipe through the ground.
That's the one I'm familiar with, yeah.
Right. You're pushing a pipe through the ground.
So pushing it, is there like a machine that's pushing it, or
well, you have big hydraulic jacks in the back of you dig a hole in the ground. It's not fully trenchless. You do have.
Yeah, of course you got something. Right. You got to get down there.
You got to get down through all the utilities, and so you go level, and so you get these big hydraulic jacks, and you're pushing this pipe through the ground. But you say, well, how do I remove the soil? And you actually have a remote controlled tunneling machine that's at the very front of that. And so that's digging through the ground, taking all that dirt, and it's mixing with liquid, like water.
Yep.
And it gets pumped back to the surface where you take all the solids out of the ground.
So it's like drilling, auger drilling?
It's kind of like auger boring. Okay. It works well below groundwater. In the Boston area, most of our area is below groundwater, right on the waterfront. There's other methods called pipe jacking or auger bore, like you just mentioned, but those don't work well below groundwater.
What's an auger bore?
Well, an auger bore is like a pipe jack also, where you're pushing pipe to the ground, but instead the face of the machine it allows the groundwater to come flowing in, and I have like a big screw.
It's a short version, but really big diameter.
And so the screw goes into the ground inside the pipe, and it's digging up the dirt, and it pulls all that dirt.
So you pull the whole thing backwards again, and you come out with this big lump of dirt.
You still got to get a pipe in there, though.
Clamshell kind of thing, or backhoe?
Yeah, you might have a clamshell. It might be a bucket at the end, a big bucket.
Big bucket. Yeah.
and then every once in a while they'll take that bucket when it gets full, and they'll pull it up onto the ground, and they'll dump it into a dump truck and drive it away, and then they'll put the bucket back down in the ground.
Now I have a fun question for you while we're on the subject. You said basically it's no dig. Now, and especially in an urban environment like Boston, an old historic city, we've got lines and utilities that have no ownership, I guess you could say. Nobody wants to own what's there, and there's not always reliable plans, and some of them are several hundred years old and have moved quite a distance. So how do you gauge for that? Do you do a boring program still in advance?
Well, the boring program, or otherwise known as the geotechnical boring program, is critical that you do that. So you need to know what type of dirt you're going through, whether it's rock, solid, sand, or glacial till, which we have a lot of here. But with respect to understanding utilities, it's always good to go back and look at old maps and old plans.
If they're available.
If they're available.
Right.
But another way to find out is something called ground penetrating radar. Okay, which is actually a device that goes along the surface, and it uses radar signals going into the ground.
How deep? How deep can it go?
Oh, 25, 30 feet.
Oh, that's pretty good.
It depends on the ground conditions too, though. There's other methods called seismic refraction, which you can go down and figure out where the rock is. So there's all types of tools you can use to help understand and identify the ground. Don't forget, I'm going through that ground. I don't want any mistakes.
Right.
So
Right.
I want to know as much
This-
about the ground.
This goes way beyond what does DigSafe do?
DigSafe marks the known utilities.
Yes.
Not the unknown utilities.
Okay, so you get the companies,
And they're
the
not
ones
always
that
right.
are used and claimed.
Right.
Yes,
Okay.
claimed. So that somebody's willing to own the liability on that,
Right.
and go after you if you harm it too.
Yes.
Right.
But
What kind of things have you run into underground that were like surprises?
One of my more interesting things that I found was in the old days before the internet, they had pneumatic tubes, just like at the bank, where you go up to the bank, you drive up and you put that thing in the device and it goes up. Well, they had pneumatic tubes that ran all around downtown Boston.
Underground?
Really?
Underground.
I didn't know this.
Holy cow.
Are they still operative? We gotta find these.
No, they're not operative, but
Oh, that's too
I found
bad.
them.
Oh, that's too
I
bad.
remember one job we did, they actually went right through the middle of a sewer.
Wow.
So we had to cut them out, but yeah.
Yeah, that wouldn't
So
be fun.
They built
Right.
a sewer around them.
So if you were shipping, say, somebody's money and that thing broke in the middle of the sewer, that would be bad for the pneumatic tube, I take it.
Well, yeah, that's what I call cash down the drain.
Yeah. Oh boy. Oh boy. Cheesy jokes. That's a good way to go. So
It all goes downhill.
I'm actually, now I know the show isn't supposed to be about pneumatic tubes, but I'm like totally fascinated. Where was this? What area of the?
This was in the Copley Square area.
Do you think that was more in that area? Was that like an older financial, and
The
that's why they
older
were there?
financial- Yeah, many years ago in the Copley Square area was more residential than what you have there now. There was, matter of fact, there was a museum there, an art museum there at one time. MIT was there at one time
Yep, I
before
know
it moved
that.
over to Cambridge. So that area there, but it was more for all the financial district. Now, why did they go out that far? I'm not sure, but yeah, they ran all over downtown. Steam lines
A little
run all over
insider
there.
trading going on quietly. I don't know what's going
Yeah,
on
quick
there.
way to ship money across town.
Oh, that
Well,
would've been-
money, important documents. That was before the days of faxes and.
Yeah.
And now going back into the trenchless technology, I was asking you earlier, and maybe you can expand on it a little bit. Because you're in an urban area, it seems like with a lot of jobs, especially now, there's a lot of things going into restoration and retrofitting, different things, and you need equipment that can work in very limited workroom. So is that becoming the norm? Are you seeing the machines getting more powerful but reducing in laydown or necessary yard
So
space
what-
to operate
What's
in?
the
or-
stuff? First, we haven't really said what the stuff. What's taking up all the space?
Oh,
What
God.
is all the?
All-
Existing infrastructure.
Yeah, all,
Yeah, no,
all
no,
the
no, I know
underground
that stuff, I know
utilities,
that.
subway tunnels.
No, I mean of the equipment. What's the big equipment that we're talking that's taking up all the space?
Well, it's really the surface equipment that
Yeah.
supports what's going into the ground. One thing I did not mention before I forget, I was talking strictly new installation, but there's also something called trenchless rehab methods, where you might use what they call a cured-in-place pipe, which is actually a sock with glue on it.
Oh, I can
lack of
picture it.
better
You're
word.
sleeving it
And,
inside.
Yeah, so you either put a new hole in the ground or you maintain an existing hole. And so sometimes you need to fix that existing hole first and making that strong. Because a lot of the pipes in the Boston area, I've dealt with pipes from 1850s.
Yeah, I can
and,
imagine.
1910.
So things that are like made out of like wood that's like
Wood.
bound,
wood,
wrapped
rock.
wood, like.
And they've withheld the abuse of all the snow melt we put down?
Yeah, surprisingly.
Really? Actually, I'm shocked to hear that.
It wasn't like. Would you say once everything stays wet, they do okay, and then once things are
If it gets
totally
dry, yeah.
they're okay, but when you're in the middle,
No,
No, when
actually,
dry
when they
is
dry out,
no
it's not
good.
good.
Oh, not good.
Not But you have also like clay pipe. Clay pipe is not, in the old days, was not done very well. And so we now have to fix it in place. Because we just can't shut down someone's house where they have to use their toilets all the time.
right? Yeah.
It's not good.
Oh, this was for a sewage system.
This is for a sewage
Clay
system.
pipes. Wow.
Oh, yeah, and I've seen wood water pipes.
Yes, wood water pipe. I've heard of that. I haven't seen any, but I've heard about that. And they're still operative?
Yes, not that many, but there are.
Wow.
Who was this?
This was
Boston?
in downtown Boston.
You just never know what you're gonna find, do you?
Yeah, I mean, most of them have been replaced, but there's still a lot of old pipes that you have to fix and maintain. It's like the blood vessels in your body, in your nerve system. It's all on the ground. It's what makes the big city
Yeah.
work. So you have all these utilities all over the place, and you're pumping blood, or you got nerve systems, or you got everything going on, and you have to make sure that they are maintained well. Otherwise, if it gets clogged, something happens bad.
Oh, I've been there. No,
Why are we, that's not a funny joke.
No, that's
though.
not really
That's
funny
not
at
really funny.
But a lot of the times we're putting, the city's getting bigger and bigger, and so you have to have bigger pipes now. And so a lot of times you can't just,
Capacity.
capacity issues. You can't just go out and rehab the pipes, you have to put in bigger pipes. And so that's where you start having a lot of things where you have to put microtunneling or directional drilling or auger bore or pipe methods and pipe tube methods.
That's a lot of phrases we're getting here.
I'm actually interested to know if you are doing like, say you're increasing the capacity in a main line, and then you have to go to, like you said, individual houses. To what point can you reach their housing system? I mean, do you go into the person's right away or their yard?
You tunnel right through people's yards.
But how do you connect?
Well,
how do you
can.
make the
It depends.
connection?
In the Boston area, most of your sewers are in public right of way.
Right.
Okay?
Yep.
There are other areas of the country where the sewers run behind the houses, and that's what they call an easement. It's a little bit more difficult. Also, there's an issue with property lines. That the city will own up to the property line. Some cities will only own the main and not the lateral.
Okay.
But the laterals leak.
Yes.
Right.
Okay, and not only they leak outward, but they take, when it rains, all that water goes in.
Yes.
Okay, and so that water takes up capacity in the pipe. And when that happens, if you get too much water and it rains, you have what you call combined sewer overflows, and that's when it flows out into Boston Harbor or Charles River or Stony Brook, and that's always a problem. So the state, the MWRA, and the Boston Water and Sewer, and a lot of the other surrounding cities and towns have gone through a major program to reduce that amount. And that's one of the good reasons of where you want to rehab a pipe, where you want to put a liner inside of it, because you're keeping the groundwater from coming in. Now, back to your question on the lateral, like we call laterals.
So-
You can line right up to the building, but you have to get permission from the
From the
building
owner? Oh, the building owner.
And you could even put in new lines.
You think that they would like
So you're
an
saying you can actually
opportunity
make
to
a
do
turn,
it while
you
you're
can line
there?
it on a straightaway, and then when a pipe comes off sideways, you can make the turn?
Well, you don't make the turn. What it is there'll be a device that comes down.
What's it lot like? What kind of device is this? Like a robot?
Do we have
Yeah, it's a
slides?
robot. It's a robot.
Now we're talking.
Do we have slides?
No
No,
robot
no
pictures.
slides of that, I'm sorry.
Oh, that's
But
all right.
just everybody use their imagination of
I know,
robot.
I like robots.
And, well, think of this as the hole. This is the main pipe,
Yeah.
okay? So you get this device comes down and it shoots up a tube up into that pipe, and it helps seal that pipe. But there's other ways when you might want to put in new pipe, and you get something called pipe ramming, and so it's like taking a hammer and hitting it through the ground, and it will
Yeah.
go through the ground until you get to the point where you're interested in, hopefully, and then you just drag a new pipe in behind it.
And you're operating this on, you were saying you do it with a remote control. Were you talking like almost like a joystick? The way you're...
Yeah, well, the pipe ramming is not so much remote control. It's just point and aim, and hope for the
Yeah.
best.
Oh, boy.
Yeah.
So
But
that's
you have
not
to
the
understand
cutting edge
ground.
technology. That's
no,
one
but the
step
cutting
back.
edge technology is the directional drilling, and it is the microtunneling. And I think I brought slides on that.
Yeah, what kind of precision do you get on that when you're going in the ground, you can fully tell exactly where you are at all times?
Yes, it's laser guided. It might have a gyroscope in it, and it's precise to a 1 inch, plus or minus 1 inch.
That's awesome.
Yeah, and that's all.
This would have been a good show to do live. We could have gone out to the machine and had you explain the parts to us.
Yeah.
It would have been fun.
It's very precise. However, if you're in a very soft ground, maintaining that alignment control is very difficult because the machine's going to want to sink
Yeah.
just because of the weight of it. And even though you're trying to steer up, because you can't steer this machine. I may not have said, I'm on the National Standards Committee, and we're revising those standards so that when you get to the bigger machines in the soft ground, it's now 3% of the diameter of the machine. So you might be off by 3 inches, and you're still okay, because 3 inches is 100-something inches. So.
But,
Right.
oh, yeah, I was going to say, what is that like, 2 miles away? Or do you
Well,
never
you
do
don't
it
go
that
2
far?
miles
Right.
at a time.
Okay, what is the typical distance?
Most of the microtunneling under 1,000 feet at
Okay.
a time. So you have a hole in the ground where you start, and 1,000 feet away, you have another hole in the ground called a receiving shaft. So you're
Right.
aiming for that, and then you'll start at another hole and go
You
back
just
to that
piggyback.
distance.
Okay.
But I've gone as much as 1,800 feet.
Okay. So that's
1,800 feet
really,
pretty far.
that's
The
doable.
world record's about 3,200.
That's amazing. Now, what's the size of the engine pushing that pipe to get it 1,800 feet?
It's not really an engine, it's big hydraulic jacks, just like when you jack, if you go to an auto dealer, not an auto dealer, a repair place, and they drive your car up on these ramps,
Yep.
and these big jacks push the car way up in the,
Oh, yeah,
in the
yeah.
air, same thing. So you imagine all that weight of that, it's gonna have the strength to push it up.
Yeah.
Same idea, but I'm pushing that way instead.
Yeah.
So I'd imagine you got to keep, once you're trying to do this, there's no stopping, right? You got to keep on pushing this thing.
Well,
or
you
is it
have to
gonna get
connect them,
jammed?
right?
Yeah, you have to stop and make connections.
Make
and
connections,
You do
but-
stop overnight. But yeah, once you start, you don't, you
Try not to stop.
You try not to stop, right. And with directional drilling, you see a lot of smaller machines that, they're very small, like the size of a car.
But they have a lot of power.
They have some power, but those only go up to about 800 feet.
Still,
But
that's
then
pretty
you
good.
have really big machines, which is about the size of a tractor trailer rig. And those can go, 6,500, 7,000 feet.
Whoa.
And
And 48-inch pipe.
That must be for like a new, completely undeveloped field in the middle of the Midwest where there's no
right, that's what I was
permitting
thinking.
issues.
When
You
you're in
need to
downtown
go that
Boston,
much
I mean,
room.
there's things crisscrossing in every direction.
You better know
You
where
wanna-
everything is.
So you want to
I
be
just-
deeper than everything, because you don't want to take a risk
You
of any of
wanna
the
be
crisscrossing
deeper.
stuff.
Oh, you want to be deeper?
You want to be deeper. I just finished a project in Atlanta, in downtown Atlanta, a place called
That's the city.
Freetown, very historical area.
Oh, yeah.
And we put in, it was like about 1,800 feet uphill, and we put in high voltage cable.
Wow.
And so we drilled down, we figured out where all the utilities were, we drilled down, stayed down deep enough, but then we also knew there was rock in the area, so that's when we used some of that geophysical methods called seismic refraction to determine where the top of the rock was. So we stayed above the rock, but below the utilities, and managed to come back up 1,800 feet away. And
Do they have that marl down there, or what do they have, limestone?
they have some marl, yes. Yeah, most of the
So
marl
what's
is more
more,
coastal.
what do we?
Marl, it's kind of almost like our till, I think. It's very hard condensed.
Also, it's like rocks all pressed up against each other.
Highly
It's
weathered
gonna-
rock.
If you took
Okay.
it out of the ground and you poke at it, it collapses. But when it's in the
pushed
ground and
together,
compressed,
it's like
it's very
really hard.
strong. Yeah.
I can
Yeah,
picture it.
highly
Yeah, like-
weathered rock. It's powdered rock, for lack of a better word.
Yeah.
Maybe some stones in it.
That's how I think of till too.
Yeah.
Yeah, right.
Powdered
so
rock.
everybody,
It's
like
kind of
glacial
pretty, too.
tilts, it's the boulders that are all up against each other.
I actually like drilling in marl.
Oh, you do? It's steady?
Oh, it's solid, it's predictable.
So that's what do you do the drilling directly yourself, or do you just
No,
set the programs?
I design all of it, but I work closely with a lot of contractors in design, build, or engineer. We're the engineers, and we bring in the contractors.
But that's when the drillers are happy, especially if they're getting paid by the foot. They like that nice, smooth, steady roll,
I
right?
tell you, I've seen some happy drill. I mean, because one thing we haven't talked about is like the method that I've seen done a couple of times, where it's guys on their back, like either with jackhammers or shovels,
What?
rolling in, shoveling, rolling out.
Whoa,
rolling,
I haven't
shoveling,
seen this.
rolling.
What?
That's what we call an open face pipe jack, where the person has access to the face, and all in front of us is nothing but dirt. Doesn't work very well below groundwater.
No,
Yeah,
Because the
no.
I
groundwater
would say that
flows
would
in.
be bad.
Right. Yes, that would
Those
be
must have to
We
be
need a
much
snorkel.
larger, though.
No,
is there a-
actually, OSHA
Yeah.
says it's 42 inches or greater.
Yeah, I
42
saw this in
inches.
But
about
I've seen
42 inch
people. I've
pipe.
seen
Oh
people
my
going
God.
36-inch pipe.
And they were so
Are they very
happy.
tiny
They loved
people?
it.
Yeah.
Yeah, and
Not
they
me.
were.
Are these
they
the
were so-
sandhogs? Is that what they're called?
No,
Sandhogs?
sandhogs. You may see some sandhogs. Sandhogs
That's
is
what they like to call
a,
themselves.
Yeah, they're actually a group of
have a name, I can't
underground
remember what they call
contractors or construction people. They're very good people. They know what they're doing. They understand what they're doing, and they're very safe at what they do.
Yeah. But that's crazy. I think
They,
actually.
they loved doing it. The people who were apprentices really wanted to be in there digging. It seemed like the senior guy was the one doing the digging, and there was apprentices that wanted to be in there.
Maybe they were hoping they were going to come across a large, like, gold deposit or something. That's the only thing that would likely motivate me into a little hole that size. It's got to be good. It's got to be like
some people like it.
rubies or diamonds.
But if
Something's going to be
you're
in
in the
there.
smaller
think it's
pipe, you got to
cathartic.
crawl up the pipe, and there's only one way out.
Right.
Yeah.
And that's you have to crawl back.
Crawl back.
Sometimes they put you on a little
They had them on a little
skateboard.
track. Yeah, a skateboard thing. They're rolling them backwards.
Well, this was so much fun. I would actually, I would love if at some point we could maybe get some field shots of how it works
going
and a
out in the
special
field and
project,
that'd be awesome
and then
to do
have you
another one
back
sometime.
on maybe in the
We'll see what we
future.
can do.
Well, we loved having you on. I learned
this
a
was
lot.
great.
And even though we talked about
We
hydraulic
went astray a little bit. but
many
it was-
tools,
You think we went astray?
just a little bit.
But I have a couple of announcements that we got to
Okay.
make before the show is over. And thanks, that was awesome. And the big things coming up is we need volunteers for the Future City competition. That'll be on January 25th, am I correct?
It's coming up.
January 25th, and that's going to be at Northeastern at the Curry Student Center. And any teams, the deadline already came and went for registering at this point. But all the teams should be working hard. They're from all over New England. There's teams
And it's
all over
fun
the
to
place.
mentor.
It's very
It
fun
is
to
fun
come
to
in.
mentor.
You don't have to be an engineer to mentor anybody who is in what we call a STEM professional society, which means, not society, it's a STEM profession that could be anything. That means somehow your job somehow involves science, technology, engineering, or mathematics, and that's a big, broad range. And even if you're not, we need other volunteers too.
EngineeringYourFuture.org, is that where they can go?
EngineeringYourFuture.org,
There'll be a
it's-
link for a sign up, or what should they look
There
for?
is that'll bounce you right into the site, and it will say volunteers as one of the click tabs, and
Okay.
you can volunteer.
All right, so look for the volunteer.
Yep.
stuff. Okay.
And also happening, the Model Bridge Contest is underway right
Yes,
now.
exciting.
This year, we've announced the materials, and the materials are plastic silverware
This
and
is going to
masking
be
tape.
interesting.
Well, and I know that schools are working hard at it. It's not too late to register for that one.
Nope.
So anybody who wants in, just sign on up,
Also, EngineeringYourFuture.org,
engineeringfuture.org.
Model Bridge.
Yep, we just had ThinkFest. ThinkFest is done. We just finished up all the bridge tours for the winter time, but still doing plenty of classroom visits. And for everything we do, we always need volunteers. So anybody out there, engineeringyourfuture.org. If you want to get your school involved, just speak up and connect with us, and we'll be happy to arrange something.
All right, well, we
And
want to thank you, really.
Thanks, Dennis. That was great.
Thanks a lot.
Thank you.
Good.
We
We're
hope to
glad
see
be
you
here.
back with a little action.
Yes.
We'll see what we can do.
All right,
All right, everybody, see you next month.
bye-bye.
Bye-bye.